Here we go.
Okay.
What's
So
a line?
a line is a connection between two or more points.
Mm-hmm. Two or more points. Two or more points. Great.
Sharing at least one axis.
And what does it have to be?
X or Y. It has to be straight.
Straight. So two or more points, and they have to be.
Hey, what's that thing on your pen?
It's a cool stylus. Oops, not straights. Straight. Straight. Okay, whatever.
What is that on your?
It's a little,
Does it move?
yeah. It helps. Yeah. So how do you name a ray?
You name a ray. Like labeling a ray?
Yeah, how do you name it and call
Is
it?
it recording?
What do you start with first? It's recording, yeah.
You start with the letter of with the point of origin, and then you
The end point, right?
the end point.
So if I had this ray right here, what the heck? I'm on eraser, that's what I have. Let's make it a rainbow. Okay, here we
Yay,
go.
rainbows!
Oh, it's not working. We'll make it red. All right, so say we have this ray right here.
Mm-hmm.
What do I call that ray?
B-A, with a line over it, but the line
Right.
has an arrow to the right.
Right. So you start at the end point and go forth, right? What's the definition of a line segment?
A line segment is a line that does not go on forever.
Yeah,
in either
pretty much.
direction, so
Has
it has
points.
two endpoints.
Yeah. What's this symbol stand for except for the symbol?
That symbol is
Ah!
union, and that is where they join. So it's where one line becomes another, or what does that line turn into?
Okay, so it's where things join, right?
Mm-hmm.
So it's together.
Yeah.
All right.
Like united. Union.
United. Union. Good. What about
And that is
This one.
intersection.
intersection? Okay.
That is where two or more lines intersect.
Just lines
Or rays.
or rays?
Line segments.
So what is the point? What's that called where two rays join?
Vertex.
Vertex. And when two rays unite, they form what? An angle. Ding, 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 ding. All right, let's. So, name the ray that has the endpoint of A and goes in the direction of C. There's two names for it.
AB and BC. No, sorry. AC and BC. The line going from left to right. Always left to right, right?
Yes. Why can it... Wait. Not BC, because it starts at A, right?
Oh, AB.
AB. Do you get why?
Yeah, I get that. Sorry.
Why does AB work?
Because it has to start at the end point.
Let's start the endpoint, and this is not a real endpoint because this is a ray, right?
Mm-hmm. So that's like a
It's just a point on that
oh,
ray.
So it's,
Yeah.
It's collinear.
Nice.
Yeah.
Insertion of terms. Let's talk about collinear. Why not? What color should we make collinear?
Let's make it purple. Wait, did we start a new video? Yeah.
We're just on the... And let's talk about what collinear means.
Will it be able to hear me from here?
Yeah. So what does collinear mean?
So, collinearity is when there are two or more points on when there are 3 points on the same line, then all those points would be collinear. You don't mind I'm saying this out now, do you?
No. So what if, so you're saying it's 3 points? What if there are 2 points on the same line? Are they collinear?
Well, no, because any 2 points on a graph would be a line.
Yeah.
Because I mean, like, boom, boom. See?
Right.
And boom.
If they're in a line.
Yeah, then they're in a line. Now, 3 points can also make a triangle.
Right. It's points that lay on the same line are called collinear. It doesn't have to be 3.
Well, it's 3 or more. So that's why.
It says points that lie on the same line. They just use an example of 3, right?
Yeah.
But if somebody, I think they use, you know why they use 3? Because then if they have one that's not on the line, then it helps you define collinear, because collinear, when one of them's not on the line, then you can't say any of them are collinear, right? Yeah. They all have to be collinear if it says, right? So if a point's between 2 other points, all 3 of the points must be collinear. 1.2 starts out with measuring segments. Yeah, and measuring angles. But measuring segments, pretty straightforward.
The
The distance between the points, yeah. Okay. And they use a number line a lot of the time. So, if you had, it's not. Here we go, angles. An acute angle.
Okay, so an acute angle is an angle that measures greater than 0 degrees and less than 90.
All right. So how would we write that? We would say 0 is less than this angle, right? Angle X, which is
Which is then
less than 90 degrees. Okay. Now we have a right angle. What's wrong with this thing? I can just use my finger. A right angle.
I think I have a better stylus if you want it.
That's okay.
I think that stylus is fine though.
Right angle.
Here, you should pause.
It's okay. So the right angle.
So a right angle is an angle that is exactly 90 degrees. So it actually equals that. It's not less than or greater than.
It equals 90 degrees. And it's formed by.
And it's formed by.
They didn't ask you that, but I'm just asking you. What kind of lines make a right angle?
Wait, what?
What kind of lines make a right angle?
Perpendicular.
Yeah. Obtuse.
Wait, we forgot to say that an angle is made by 2 rays.
Okay, let's put that down. An angle is formed by 2 rays.
That connect.
Right. Okay. And now we have obtuse.
Like fish.
Obtuse angle.
So an obtuse angle is an angle that is greater than 90 and less than 180. So it's kind of like the opposite of, it is the opposite of an acute angle.
Okay.
You can always remember because obtuse and acute. Scout is acute.
What about
So acute.
a straight angle? Straight angle.
A straight angle is an angle that measures exactly 180 degrees.
Mm-hmm.
And it's a straight line between one point and a scalp.
Okay.
So it's literally just like any 2 points. It's a line, basically.
All right. What about parts of a degree? What are parts of a degree called? What's a degree made up of?
A degree is made up of minutes and seconds.
Mm-hmm.
And it can be converted from decimals.
Mm-hmm. Yeah.
So
How many minutes are in a degree?
minutes in a degree are 60, and there are 60 seconds in a minute.
All
Just
right.
like in time.
Right. Great. So I'm going to give you a pretend problem.
Okay.
So
Or did you pause it? Is it paused or is it playing?
I'm going to say the directions and then I'll pause it.
Scout.
41 2/5 Change it. That's in degrees, so change it to degrees and minutes.
or seconds.
Yeah.
Minutes.
Should I pause it?
Yeah.
So I'm actually just going to explain this really fast, okay? So you took that 2/5 and you made it 41 and 4/10, right?
I don't have to do, but I can.
But you can, and then you multiply it by 60 because there's 60
Mm-hmm.
in a degree, right?
Yeah.
So then you got 240 over 10, which is 24. So it's 41 degrees and 24 minutes. I almost said seconds. So we're going to change 60 degrees and 45 seconds into degrees. Explain. So you just took 45 over 60, yeah? And then simplified it to 3/4?
Sounds cool. Yeah.
So you got 60 degrees, 60 and 3/4 degrees, right? Great. It means to be a drummer. No. Tell me what it means to be
I can drum.
congruent.
Two things,
Mm-hmm.
two angles or line segments are congruent when they have the same measure, whether that be an angle measure or the measure of a line or segment or a ray.
Same. Can you measure a ray?
No, well, not a ray or a line, but same
Segment.
measure or segment, same angle or segment.
Exactly.
So like two angles that are 90 degrees are
Mm-hmm.
the same angle.
And sometimes they use these little things called,
Are congruent, not the same angle, but are congruent. And they'll put little hatch marks.
yes,
And the symbol for congruent is the equals with the squiggly over it.
equals with little tilde on it.
The
Looks
squiggly.
like, I know, it looks like a tilde from Spanish.
Can we call it a squiggly?
We can call it a squiggly.
Squiggly.
Let's call it a squiggly. Okay, back to recording. So tell me about the number of degrees in a clock.
So in a clock, the distance between two numbers, like, the 1 and the 2 and the 3, is 30.
30
And
degrees.
because a clock is a circle, and 30 times 12 is 360,
Mm-hmm.
a clock is 360 degrees because it's a awesome circle.
All right.
Or a pear, like an oval shaped thing.
Okay, so let me give you a couple of
Sorry, but ovals are so much cooler than circles.
questions. Let me say that. If it's 420, what angle is it going to be? All right.
We will draw it on the clock.
Okay.
There. So it's going to be...
So maybe I should use a different color. All right. So this hand, right, is going to be...
At the 4. And
Well,
so
that-
both hands are going to be at the 4.
Well, that was really not such a smart problem. I wasn't thinking of 4 when I
the
thought of the
angle
20.
is 180 degrees.
The angle's actually 0 degrees because the hands are on the same thing.
Whoa.
Well, actually, it's a little bit after, right? Let's think about this. So it's 420, but this little hand, right, is going to be a third of the way to the 5. So it's going to be what? It's going to be a very small angle between 4 and a third of the way to the 5. So it's going to be, what's a third of this?
It's going to be 10 degrees.
10 degrees. That was actually harder than I thought. It was harder and easier.
Wait, what?
Okay, let's try another one.
Awesome.
All right, Connor. So let's ask. Say it's 11:40. 11.
That is also 10 degrees according to my calculations and speculations.
You think that that's 10 degrees?
No, I'm just kidding.
Let's draw the hands. You want me to draw?
I'm just looking for my spring.
I'm gonna.
The 8 and the 10. And no, the 8 and the 11.
Right,
So it's going
so-
to be 1, 2, 3. So that's going to be 90 degrees.
Mm-hmm.
But then there's a
Plus-
little left over because of the space between. Because the clock is mechanically sound.
Mm-hmm.
And so it's not broken.
Even though it doesn't look like it.
Yeah, although it's not a real clock.
And it's
So yeah, it's going to be the 40 is going to
Make this.
make this. Oh shoot! How do you word it? That's going to be 2/3 of the way there.
Yeah, 2/3 of the way between
So that's
this
going to be
and this.
2/3 of 30. So that's going to be 20. So it's going to be 110.
Excellent.
If that made sense, human.
What is a theorem?
A theorem is an idea or concept that is used in a proof. So, like the Pythagorean theorem, or other theorems. Like what's another example?
So it's actually, they call it a math statement. Can it be proven?
Yes, it
Yes.
can be proven.
Compared to.
Compared to what?
Well, compared to what?
Postulates? No, postulates can also be proven. Then they are blank.
Yeah. What are they?
Then they are congruent.
Yeah. They are. That's actually theorem 1.
Very important theorem.
And then, if two angles are straight angles, they are.
Did that shoot you?
Yeah.
I'm so sorry. Where did it hit you?
In the leg. It's no big deal. If two angles are straight
Did it hurt?
angles, no.
Oh,
Hurts a spring. If two angles are straight angles, they are.
Face.
If two angles are right angles, they are.
Two angles are right angles. They are congruent.
Correct. If two angles are acute,
And they are not necessarily congruent, as there are several different measurements of being acute.
exactly. Okay,
So they could be like 45 degrees or 35.
so
A midpoint is what separates two congruent segments.
and when you separate something into two congruent segments, what's that called?
Bisecting.
Bisecting. So, what about trisecting? What is trisecting?
Trisecting is when two points or rays divide a segment or angle into three congruent parts.
Exactly. So is it also the converse of that? If you divide something into three congruent parts, is that called trisecting? Can you reverse the definition?
Sorry. Could you repeat?
Yes. So you said trisecting is when 2 points or rays divide something into three congruent parts. Can I reverse that definition and say the converse, and is it true? If I divide something into three congruent parts, does that mean I'm trisecting?
Yes.
Yes, and the reason why?
It's because it's definition.
Awesome!
Okay, go ahead.
Alright, do you remember what a postulate is?
A postulate is something that's like agreed upon. So
Yeah.
it's not necessarily proven, but
Right. It's an assumption that's okay to base something on, right?
Mhm.
Alright. What about a definition? What's a definition?
A definition is like a definition of a theorem or of a line.
It's the meaning of something, right?
Yeah.
And you already told me something really important about definitions.
Is that they're always going to be true. The contrapositive,
You mean the converse?
I mean the converse is always going to be true.
Exactly. converse is true. Look, I wrote it right there. Okay, so if this is a statement, if P then Q, what's this called right here?
If Q, then P.
What's
so
that
that's
called?
the other way around. That would be the contrapositive. I mean, the converse.
Yeah, the converse. Sneakers. So for definitions, you already said this, converse is always true.
Mm-hmm.
Okay. And theorems and postulates are not always reversible, right?
Mm-hmm.
That's important. Okay. So if P then Q is called a conditional statement, right? You did. You learned about conditional. It just means the if part is called the hypothesis and the P part is the
It's
conclusion.
called the conclusion,
Yeah,
okay.
you did learn it. You just probably didn't fixate on that. Yeah. Okay. So if Q then P is called the. You already said it.
The contrapositive. The converse.
The converse. Contrapositive has a not in it, so don't think of it that way. Okay.
Mm-hmm. Yeah.
All right. What about not P, not Q? What's that called?
Then that is inverse.
Mm-hmm.
And if not P, then not Q. That is contrapositive. No.
Not
if not Q, then
not P. That's a contrapositive. And I would recommend writing this out on your paper anytime that they give you a problem like that,
Mm-hmm.
the Q and P stuff, because it's easier if you can relate it back to an actual thing that's written out for you.
Yeah.
Okay. Right. If A then B is the statement, what's the converse of that?
If B, then A.
If B then A. What's the inverse of this statement?
If not A, then not B.
Not A, not B. And you make the little not sign.
It could be squiggly.
So not A, not B. And that's called the
Inverse,
yes.
And then the contrapositive
Mm-hmm.
is not B, then not A.
Yeah.
And the contrapositive is always true if the starting statement is true as well.
Great.
That's
Okay.
the only way it is true, is if the other one's true.
Okay. What about not? Negation. Something's not, then
Then
it
it's
is. Right.
It's positive.
Okay.
Can I not go to the bathroom? Wait. I'm scouting.
Can I not do this? Okay. So we've gone over converse, right?
Mm-hmm.
We've gone over inverse. So if a statement is P, then Q, the converse is
Not P, not Q.
no. Converse doesn't have
the
nots.
converse is Q, not Q, then P.
Yes. The inverse
Is not P, then not Q. Make sure that
Yeah.
you don't do the inverse of the converse.
right. The inverse of the converse is called the
Contrapositive.
right.
So just be careful and make sure
Be
you're doing
careful.
the original statement.
So contraposit, yeah, that's why I write the original statement out. Contrapositive, not
Q, then not P.
not P. Okay. All right. What's the converse? If you live in Atlanta, then you live in Georgia.
If you live in Georgia, then you live in Atlanta, and that's
Is
not
that true? Not necessarily true, right? How about the inverse of if you live in Atlanta, then you live in Georgia?
That is true. So the contrapositive of that would be true.
Are you sure? Oh, yeah. Well,
Mm-hmm.
if you don't live in Atlanta, then you don't live in Georgia? That's the inverse.
No, it would be that's the
The contrapositive is you don't live in Georgia.
If you don't live in Georgia, then you don't live in Atlanta.
Yeah, you can't live in Atlanta if you don't live in Georgia.
If you live in another Atlanta.
You're absolutely right. Q. So, if a conditional statement is true,
then its contrapositive is also true.
Mm-hmm. Make up one for me.
If you cry, then you are sad. The converse is if you are sad, you cry, and that's not always true.
Okay.
And the contrapositive is if you do not cry, you are not sad, which is also not true. But the no, sorry, that was the inverse. The contrapositive is if you do not cry,
You are not
then you
sad.
are not sad.
Okay.
No, it says if you are not sad, you do not cry.
Okay. If P, then Q. They show it in this funky way. If not Q, then not P.
If A, then B. And
Okay.
if B, then C,
Okay.
that would mean that if A, then C. Because they
Right.
all lead to each other.
Yes.
So an example is if you study hard, then you get good grades. That's if A, then B. And if you get good grades, you make your family proud.
Mm-hmm.
That's B to C. So
Mhm.
so A to C would be if you study, then you make your family proud.
Excellent. Okay. What about, I'm looking at this thing. Whoa. I'm gonna pause.